It's solid red. Perfect.
It's red.
We're still waiting on that.
Sorry, yeah, Rogers.
Yeah, we can go ahead. So, cut this part. Okay, everyone, we're going to go ahead and get started. Make your way back to your seats.
I think we're still waiting on our first presenter. Okay.
I was looking at the time and we're right at that.
Gotcha.
So, but in a couple minutes.
Okay.
Are y'all going to be like hovering there or kind of standing over here more?
I think whoever's speaking will probably be over there.
Probably better over
But
there.
it doesn't matter. Do you want?
I can move it.
Yep.
The
Okay.
webcam, the feed's not quite as easily moved as the main camera.
What's the?
Were you gonna stand closer to the slide? Wherever you gonna
Wherever they
stand?
want.
And then he asked us where we wanted. Yeah.
Oh, actually, it could have been hard with. I think it's about the slides.
Oh, with the mic.
Yeah.
Mike's gonna
coffee.
What are you gonna say?
I'm gonna try to see what the mixture of audience is. You're like really similar, like doctor communication stuff. Whenever you're ready, let me do it all.
Mute at the bottom.
I'll probably sit with you.
Can I do a quick mic check?
Check.
I'll stand.
Check.
Yes. Do that again?
Check. Good? You're good? Ooh. I'm going to hit the mic off real quick. We got to tell you something. Oh, okay. Alright, I'll dance. Alright, good morning, everybody. Good morning. Before we get started, just a quick poll. How many of you are managers in the audience? How many of you are Devops people? How many of you are coders? How many of you are not raising your hand? Just what I thought. Quick math. Alright, so what we're going to talk today about is a system that we've been using inside of Cisco. We've open sourced it. And we're doing this talk at AppSec USA, AppSec California, and now we're doing it here. And you've got the core development team with you. So everybody on this side, we're going to be talking through different things. So first off, a little bit about the core development team. I'll let them introduce themselves.
Okay. Let's take on first. My name is Blake Hitchcock. Been at Cisco for about 7.5 years now. Doing a mixture of pen testing and development of security tools.
And I'm Brian Manifold. Very similar background to Blake's. I've been at Cisco about 6 years here, and again, pen testing and internal tool development.
My name is Roger Seagle, principal engineer in Cisco. Been for like 11 years now, I guess. Penetration testing for about 8 of those. Then did security research, then did cloud security, then did threat intelligence, big data. Yeah. So what we're going to talk about first is like development trends, why we actually developed this tool, and kind of get to the point of what the tool does. We're going to run through some demos. We're going to talk to you about how to extend it. It's all open source on GitLab. We'll show you how to get to it, licensing, all that good stuff. Quick little preview thing. Development trends, what's happening in the industry, and this is probably pretty evident to everybody in the crowd, but this helps us frame the discussion. Agile is huge now. It used to be huge in Cisco when I started. It was all waterfall, unfortunately. but now it's Agile, so you're talking about adaptive planning, early delivery, continuous improvement, and rapid velocity. Then we move to the DevOps combination, because that's come about, and we're really looking at the coordination of IT, QA, and development efforts with the goal of rapidly releasing products, right? Instead of releasing every quarter, it comes to like every day or every few hours, depending on how mature the team is. And then continuous delivery here, looking at how you can build, test, and release on a frequent basis, right? And so we're seeing this trending happening in the industry at large, we're seeing it happening at Cisco, and so what is the common denominator here? Anybody faster? Faster, right? Speed, agility, right? Easy setup there. So what does it look like for a company like Cisco? Our company kind of reflects the world at large because of how fractured it can be. We have multiple business units building products in any shape, any way they want, right? And so how do we do tooling to support all those and help them do development in a secure fashion? So we've got a ton of developers. They use any version control system under the sun, right? Like one of the first things you could do is say everybody use GitLab or GitHub. Doesn't really work more for us, unfortunately. So we support Git, we support Subversion, Material, ClearCase, and then we support a bunch of different CI systems for CI and whatever. And we're going to be developing products, whether they be embedded systems like phones, routers, switches, firewalls, or they could be doing software as a service offerings on any platform imaginable, EC2, OpenStack, Rackspace. So we got to support all of this, right? And so they will be spinning up new versions of products, whether they be secure or insecure, and they'll change over time, right? And so how we used to handle it, and we still do to some degree, is we do it as a checkpoint fashion, where we run something like Qualys every so often, it's scheduled, right? It might not time with the release schedule. Or we have third-party penetration testers come in and they do their assessment of the work. Or we have our internal penetration testing team, which is ASIG, which we were all on, and we still are. So this happens like this scenario where it's just like, stop. You got to stop development right now. You can't do any more features. You got to do your security tests, right? And once you pass your security tests, then you can release your version. And that's very disruptive to the business. And there's that always struggle between product features and security, right? And time to market. So there's all that struggle that has to happen. So we are changing that model to fit into the more agile, adaptive lifestyle, and do something like this, where developers can do what they need to do, and when we find security problems, they can come out to a different lane and we can help them fix it, right? But we have to empower the engineers to be able to run the tests, right, and do all that themselves. But security testing is hard, right? That's why penetration testing has grown dramatically and everybody wants to be in it now. It's a specialized field. So the continuous deployment model means this deploying code is rapidly changing all the time, right? So you can't do that pinpointed checkpoint anymore. And you have testers or developers working in isolated environments, right? We have many different data centers across the world in many different staging and development environments, and how do you handle all of those? You have many different testers who find similar things, who find similar bugs in isolation with different tools, but they don't know that this tool is better to run than this other tool, right? So it gets complex really quickly. And it's difficult to find a centralized platform to exchange all the testing ideas out there, right? We did look at what was commercially available, open source, and then at some point we said, oh, we're going to test this out and try to roll our own. Also, this is what really turns into a complex mess is security tools vary. And at the skill level required to operate them, they're usually not developer friendly. Some random hacker somewhere in the world finds a new vulnerability or a new way to scan something. They write in their favorite language. They don't adhere to a standard of output format like JSON or XML. Sometimes it's just free text. Like how do you handle all that and actually coordinate? Coverage gaps. Different tools find things better, right? That's the moral of this story. False positives, false negatives. How do you give guidance on which tools are better? And how do you do the correlations between different tools? And like I said before, very out. So it turns into like this scenario, right? Everybody's testing everything everywhere, right? And I always forget to rush things in red, but that's topical now. Yeah, that happened. Anybody know the movie it's from? War Games, yes. This is going to be themed. The system used to be named Whopper. Can anybody guess why it's not named Whopper anymore? No. an executive, it reminded an executive of hamburgers all the time. So true story. So, an idea. This is like 2.5 years ago. Is that how much ago this thing? Yeah, 2 years. So the industry's changed too. There's some tools that are doing this now, but about 2.5 years ago we started doing this. And let's come up with a platform. We used to call Blockers, now Norad. And let's make it a vulnerability clearinghouse. Now this has happened before. People have come up with systems where you can import your bug reports into a system. It'll categorize them, it'll catalog it, it'll do everything. And you're aggregating the results from multiple security testing tools that helps you determine the access posture. But we're taking it a step further and making a modular architecture to accommodate multiple security tools and actually have NORAD spin it up and run the tools for you. And then define a way that anybody can extend it. So we have a common API. So we're making such that it's easily plug in new tools, whether it be vendor or homegrown. Cisco could change on a dime and say we don't run Qualts anymore, we're going to go with Nessus. That's not happening, but it's going out there. Prevents from vendor lock-in, so we can make these decisions because everything is flawless based. And Nessus is our better product. We want to be able to shift immediately, go to that or next Jose. And we're really trying to evolve our security assessment automation with the emerging tools and the emerging threats that are out there. Some hacker finds writes a new tool that we really like. Let's put it in the environment as fast as possible, right? So let's do that. And this will allow us, if we create an API around the whole system, embed it into the testing and development lifecycle and the deployment lifecycle, aligning with Agile Devops. Some people know the Sec Devops thing that's happening, right? We're going towards that. Especially with systems like GitLab. CI system. We have an API exposed, use the API on the deployment, and everything's good. Community driven. This was a huge one that we wanted not to keep the tool inside of Cisco because it could die sometime. Let's get it out in the world, which it is. It's Apache v2, so anybody can take it, use it, run it, whatever they want to. And then we also support multiple deployment models. Our main one is a cloud offering. We had to come up with an acronym because everybody likes to do it, so it's separate service. And with a plug and play for users, so they don't have to do anything, right? We realize though that there are developers who have like parallel development environments, and we have to be able to do that. Have to be able to reach them. So we have a hybrid environment where, and a lot of security vendors already do this, where you can install a package on a node that we call Relay. It'll connect back home and register, and you can tell it that yes, that is the real relay that I want to use, and we'll run security tests from that relay, but in the cloud still is your command and control center, and the results are still stored in the cloud for us, and then we have an on-site deployment, which is not technically all the way done. We use it for a development box, but it's pretty much 90% there, 80% there now, 70% there. All right, I'm going to pass it off now. So Brian is going to talk about the architecture.
So from here on out, we'll start talking a little bit more technical detail. So if anybody has any questions, explain something clearly, let me know. So this is our overall architecture diagram. Our architecture is based around two things. One is Docker, and then everything is API driven. So here you can see is where we've got our Docker swarm in our public cloud. The reason we're using Docker is that's going to help us scale horizontally, at least that's what we're planning for. Every test that gets written into a Docker image, and then at the time someone wants to do a scan, these images get spun up as containers and reach out to the host under the test. At the heart here, we've got a Rails API. Like I said, everything is API driven, so you can either script everything up if you want, and that'll fit into your CI/CD pipeline. Or we've also got another Rails app that is the UI, which consumes the API, so you can get all the stuff through your web browser as well. Down here, we have some routing queues. So as Roger said, we have the idea of a relay. If you have a private network, you've got machines you want to scan, but they're not publicly accessible. You can run a relay inside your cloud. That'll hook up to this routing queue here, and that's how it gets its commands to know what to pull down and run. We run our own Docker registry. That's where we keep our security tests. Although we have just recently introduced the idea of running your own registry. So if there's a test that's not included. Like Roger said, we want to be very open and extensible. Or extended. So you could set up your own registry, whitelisted in your setup, and then your relay can pull tests from your own repository. Database to store everything. Up here we have console and vault. And console is used for service discovery. It's not terribly exciting. Vault, we use that for all of our secret storage, and so all of our results are encrypted at rest, as well as all usernames, passwords, configuration settings, things like that. And it's all running by an HA proxy. So this is a little example demo network that we'll kind of talk about. Something that we actually kind of use on the Norad project itself. We run in AWS. And up here we've got our, this whole thing is VPC, and up here is our public subnet, and down here is our private subnet. In the public subnet, we've got an SSH server that's exposed, and in the private, we've got a web server down here that most likely is routed through this NAT gateway, but it doesn't really matter. So some of the demo videos that will show, this is the setup that we'll be using. So real quick, some of the terminology that we use in regard to Norad. We have the idea of organizations, and it's kind of like the idea of organizations in GitHub. It's just a logical way to group things. Users are allowed to create any number of organizations they want, so they're able to organize their assets however they feel. Machine, that really is just anything that you can represent with an IP or FPGA. It could be a phone even. We don't really have a test for phones at the moment, but if we can reach it through an IP, then there's a chance we can test something on it. Services. So a service is something that runs on a machine. It's really just any application running on your machine that exposes either a TCP or UDP port. And then a security test in Norad is just a security tool that's wrapped inside the Docker. So we'll go through a real quick demonstration here to show how to pull in assets into the Norad application. Sorry. So like I said, this is going to be based around that demo AWS organization. So the first thing we'll do is create an organization. This is the demo from our AppSec talk, so it's going to be called AppSec 2016, I believe. So now we've created an organization. We'll go ahead and set it as our default. That way when we log in, it takes us straight to it. You wouldn't have to, but you can. So when we go there, we see that we don't have any machines right now. So let's see here. First thing we're going to do is we're going to come in. We have the idea that you can actually pull everything in from your infrastructure as a service provider automatically. Right now we support OpenStack and AWS. We could support more, but so we're going to put in our details for our AWS test network here. And what that's going to do is it's going to go out, reach out to the AWS API, and look at the EC2 instances and automatically register them in Norad. So now if we go back to our machines, we can see that we're going to have 3 machines. 2 of them are the ones that I spoke about in the earlier slide. One's an SSH, one's a web server. The third one is actually the relay, which we'll talk about later, but it was already up there, and so it just went ahead and pulled it. Okay, so real quickly to go over how you would scan some, or how a public scan would work. Like I said, everything's API driven, so you could either from your from anywhere hit the norad.cisco.com using your own JSON call or your own AJAX calls, it'll be API, it'll spin up the Docker image there, it'll reach out to your public asset, and then it'll report the results back to the API. That's the simplest case, but obviously not every asset you're ever going to own is going to be publicly accessible, hopefully, to the internet. So here we see device under test, right? Very simple. So we can show a quick scan of them here. So what we're going to do is we're going to actually enable some tests to be run. We used to have quals on by default because it was easy for Cisco people to run, but I don't really do that anymore. We're going to run the bolts package on this one, which actually will SSH into the machine and look around the various packages that you have installed to see if you have any known bad packages. This is just showing that you can edit details and describe your machine a little bit better.
Check that. It's going to do for each of those.
So now we're going to go ahead and add the SSH key to the machine. And this has changed a little bit, but we don't re-recording the demos. Literally just put the user and the key in here. In this one, it'll show that that key will show back up, but in our current version, once you put the key in, you never get it back. The only thing you can do is delete it. Again, this is encrypted at rest using Vault. So now that it has an SSH key, we're going to put another one in for the other one, of course. I won't do that. So,
It's thorough.
yes, it is. So now we can actually start a scan for that machine. And let's see, it picked it off. Then once you go back into the machine itself, there should be some results that show up. And hopefully I got that. That's what will show if the scan is still in progress. It's just a gray bar saying, hey, nothing's come back yet. And then once you, obviously each tool takes its own amount of time. It's dependent on the tools that you're running. That's how much time will actually it'll take to run this test. So we see we finished, and now it comes back and it shows us the actual raw output of what was run, and then the state that it's in. You can also get some more detailed description of what it found, and that all has to do with how the test was written and what is passing back, which Blake will talk about later. You can also collapse the picking it out. You'll notice one thing there. We have this little bug icon. We have the idea that you are also able to take your results and export them to another third-party tracker if you would like. So if you're using Jira for your issues or something like that, and something pops up, click that button. It'll send it to your Jira accounts. Okay, so that was all good and well for trying to scan the public asset, right? But we have no way to reach this machine right now, right? And so even if you could route a packet, it's never going to get there. But obviously you can't because that's got 10.0 address. So as I said before, we had the idea of a relay, which this is a machine that actually runs Docker, and it runs our relay client inside there. It phones back home, connects up to a queue, and then as you start saying you want to run scans, it pushes messages down on that queue, comes back down to the relay. The relay then reaches out to wherever, whichever registry the security test resides on, pulls it down, runs it against the host, and then sends the result back to our API. So that was what device under test is this one now. And you can see down here we've got a third box, which is our Norad relay. And so it's going to send a message on the relay then tests things, and it sends things back. There are a few requirements, but we tried to make them as simple as possible as far as getting your relay into your network and then connect back up to us. All of these, as you can see, are egress. So you don't have to open up your firewall to let things in, but you do have to let outbound access on these ports. We have a Norad IP, but you guys wouldn't be able to use it because it's only available for Cisco, but that represents wherever your Norad instance would be running. And then also, we explained the reasons as to why we need those ports open up. This is our documentation server. I don't really think there's too much here, but other than all of our stuff is thoroughly documented, you can get to that as well. It's at norad.gitlab.io/docs. And it shows how to get the relay installed and everything like that. We have a Debian package, an RPM package, things like that. And then we'll do a quick demo of the relay here.
Sorry.
So, like I said before, now we need to try and scan this private machine. It's running a web server. So we'll get onto that machine. We'll add some more tests that are relevant to it. And this one we're going to do a ZAP test. I can't remember exactly what the ZAP acid test checks for, but it's doing web-based checking. Now that we've got a test that's applicable to that server, we're going to flip over and actually deploy the relay.
It's in the description for some reason. Oh, that is the real.
That is it. There we go. So yeah, this is going to go through the relay installation real quick. Oh, right. Gotcha. Yep, that's why we're going to do this. So the way that we register relays is each organization has its own organization token. And it's meant to be somewhat of a shared secret. It's when you go into your organization dashboard, you actually see that token. It can be changed. You just click a button and it refreshes it. It's meant to be a piece of information so that when the relay connects back up and says, I want to join this organization, it knows which organization to actually join. You can see right there, there's the organization token, the registration token. That's the only thing that this is used for, is registering a relay. So that's why we didn't feel it super secret to keep hidden. And I'll also show you why we have another safeguard in place, even if that were to get out.
So does that mean organizations can't overlap? Like I can't have one asset in two organizations?
You could, it's just not gonna, they're not gonna know about each other.
Okay, that's cool.
Mm-hmm. So you can see our relay actually runs as a Docker container itself. And so we've got the relay installed. And here's where we are able to have one more safeguard. If someone were to give you your organization token and register up a relay, it's not actually going to work until you come in and verify that relay. We do have the ability to do an auto verify, which that means anyone that registers up is just automatically going to work. But we don't necessarily recommend it. We just want to have the option available to you if needed. So now we're going to start a scan, and now that scan is actually going to be running from the relay rather than from our public cloud. And you can see, I think one thing I failed to mention was you have the ability to add tests at the organization level and at the machine level. At the organization level, the test is going to apply to all machines. At the machine level, it's just going to apply to that one machine. So that's why we had you saw balls up there as a test that we run. We added that at the organization level, and then Zap passed it. And so again, it ran, it found some failing things. I'm not sure if there's actually going to be any new information.
That's it.
No, I don't think so. So there's a few things that have changed since we recorded this. Again, this was at our AppSec 2016 demo. We do also now have the idea of requirements. That's what Roger was just asking about. Requirements are, so within Cisco, we have a bunch of product security baseline requirements. And those requirements, to accurately test them, might require multiple tests to be run for that one given requirement. So you have the ability to come in and define your own requirements and say, requirement 1, you need to run tests 1, 2, and 3. Requirement 2, you need to run tests 4, 5, and 6. Things like that. So this is just a quick slide to talk about the enterprise box and the dev box as well. This is how our dev box is running. Basically, we took all the different components in our architecture, put them into Docker containers, and now they're just on one machine. As Roger said, the enterprise box really isn't fully done, but if anyone is curious, you should be able to spin up your own dev box. It may have a few quirks, but you could at least get a feel for how it works. And I think I'm going to hand it over to Blake for talking about writing actual test security.
Hey, so I'm going to talk about, so Brian's been talking about the architecture and what you can do with the system. Roger kind of set the stage for our motivation. So I'm going to go over some of the tooling that we have for developing tests, for using the API and things like that. So to start, I think Brian mentioned this, and probably Roger too, is kind of one of the fundamental pieces of our application, is that all of the tests are wrapped up into Docker images. So this gives us the ability to share code. So for those of you who don't know how Docker works, you can start with a base image and then any number of derivative images from that. There may be some limitation at some point, but in general, you can share, like if you want to have an image that has certain tools installed, then all you would have to worry about is running the specific subset of tools, or parsing the information in a certain way, given what you are trying to do. So with that in mind, we provide a base image that's got some libraries installed that make it easy to communicate back with the Norad API, as well as to fork processes, run tests, and things like that. So the kind of the fundamental idea here is that you'll use some existing tool like Nmap or something like that. Of course, you can also write something that is completely custom. So you can kind of start with there in terms of running this security tool against a target. We do have a process for the official test content, which a lot of that stuff is still, I guess, Cisco internal. So as Brian mentioned, you can point at any Docker registry you want. So there's the ability to use any test content that you would like. But as far as our process, we've been able to orchestrate a lot of CI, most of which is open source, at least the CI part of things, to automate the building of tests, getting the tests back into the API and making them available. And also, we do support running from any Docker registry. So the first piece of instrumentation I'll go over is the Norad CLI. So the what that is capable of doing right now is helping you to generate test content. It's open source as a Ruby gem. So if you go to the GitLab page, there's all kinds of instructions for installation, for a sample walkthrough and stuff like that. It's as simple as just running gem install Norad CLI on whatever platform you're going to do the test development from. And one thing I want to say really quick before I go any further, you're going to see in all these examples, everything we're doing is in Ruby. That's because that's the language that the three of us know best. So that's what a lot of the instrumentation that we have is written in Ruby, but since these tests run in a Docker image, there is no requirement to use Ruby or Python or any other language. Just something that can run in Docker is all you need to do. You can even take advantage of some of the libraries that we have written that are in Ruby by just writing your tool and doing everything complex in the language of your choice, and then the amount of Ruby you would need to parse those results and send them back to your Norad API is very small. So I just want to throw that out there because everything that you're going to see is in Ruby, and I know some people don't like Ruby. Once we're installed, the Norad CLI tool follows pretty standard in terms of being able to, every time you type a command or a subcommand, you can get help, and it's going to print usage information for what you need to do next to continue using the tool in more complex ways. So in order to start creating a test, I believe in this example we're starting from the bare bones. So we're going to assume that we don't even have an existing test directory at all. So the first thing that the tool can do is set up your repository structure. So in this example, in this example, we're just going to create a repository test called BSides Asheville, and you can just see some of the scaffolding that it's going to generate. There's going to be some defaults. Some of those things are going to be biased towards Cisco because that's the people who are using this tool the most, but everything is changeable. From there, most of what you're going to do would come under this set test command. It's the command you're going to use to create tests, whether it's spitting out scaffolding, running tests, running the tests against the test. We do have the concept of running validation tests to just kind of as a sanity check that your security tests are building properly, that they don't crash when they run, things like that. So some of the interesting commands here, if you were to run the help usage from set test, you can go from building every image that you've got. You can build specific images. This execute command actually allows you to run, rather than running the security test in a testing harness, you can just run it locally there on your box against a certain target. You can see all the output just to kind of get a feel for if it's behaving the way you would expect. And then, then there's some scaffolding commands, and the validation stuff here is what you would run if you are going to write unit tests or integration tests against your security content. The scaffolding tool is probably the one that provides it's in the top 5 for most value, because there are kind of some design choices we had to make in terms of how to structure test content. Once you get used to it, it doesn't seem like it's much, but early on there are 3 or 4 files that you have to set up for every test. So the scaffolding tool is going to let you do that from the command line. You can set the test type, you can set what options it's going to need, and things like that. So in this case, we're just going to do a simple ping test, and we're going to treat just can we reach the host as a security check. So if you run the scaffold for a ping test, you're going to see a Dockerfile Readme. So some of that goes along with pulling things in through our CI. We have a documentation server that has pulls from this Readme that shows what the test does, how it works, etc. Your manifest file, which we'll get into more in a moment, a wrapper, and then your validation tests if you are going to use those. So a sample Dockerfile, using Norad and writing your test content in Docker images does not require any sort of major expertise with Docker. Typically, it's just a few lines. It's picking what base image you want to start from. So that may be the Norad base image that we have, which is, I think, in Ubuntu 16.04 OS. Maybe it's 14.04, I can't remember. Copying over any files that you're going to need in that image. So the wrapper script, in this case, that's going to be the entry point for this Docker image. And all that means is that whenever a container is started from this image, it's going to execute this file. So the amount of Docker knowledge you need is pretty limited for, I'd say, the vast majority of use cases. The manifest file, this is one thing that's a little bit flexible. This is the structure that we have and for our CI process. Some of these things would perhaps not be relevant if you were developing your own test content, but in general, we need to specify what registry that this test is going to live in. We need to know the name of it, what version it is. The progargs, this is the command line invocation that the API is going to use when it starts this test. And then if you have any options that you want to configure, which I think in this case, we go a little further, yeah, we do have an option. We want to set the default config for the number of times that we will ping to 4. So if I go back, this is just the kind of vanilla scaffold, and now we've got this fixed up to work better with a ping test. So we're just going to specify these things for so target, and if there's a few other reserved keywords that will show up in the documentation. Those are things that, as the API is starting the test, it's going to autofill those things in for you. So the target is just going to be the machine you're going to test. If this were an authenticated scan, there's some default keywords that we have for SSHD, SSH user, and there's a few others. So those things are reserved. So in a lot of cases, I would say 95% of the tests that we've written don't require any user configuration at all. The process is they come in, the person who wants to run the test comes in, they add their machines to Norad, they add what services are running on those machines, and then the tests are able just to auto-configure from that information. So we made a conscious effort. Actually, at first we did try to bias the tool towards penetration testers. Turned out that wasn't going to be our most common use case, so we started shifting more towards developers who were going through a security process who needed to run this stuff, but didn't understand how to configure the testing tools. So instead, we just have them give us more information about their environment. So rather than configure the tool, just describe what you want to test. Even though it's in the end, it's the same information, just kind of changing that context. Cut down on a lot of our support requests in terms of how do I actually run this, what does this mean, and things like that. So it's very possible for the majority of tests that you write to require no configuration at all. And then when they do, we do have the ability to provide defaults that will make sense for most people. And then this is documentation. This is kind of the format that we follow. So it's just, you can kind of treat this as a case study. If you were writing your own documentation, of course, you could write it however you would like. But in the end, here's how it shows up in our documentation application. So each of the tests that we have, and I think we've got around 70-something now within Cisco, are going to show up here with a little bit of information so that anyone who's curious about what they're about to run, they can go read about it first. If they don't want to actually go look at the source code, which is an option if they choose, but this is kind of a happy medium. And okay, so the wrapper script here that we'll go over is kind of the bulk of where if you're developing a test, this is the bulk of the work. This is the script, or you could write a library depending on how extensive it's going to be. It's what's going to call out to the security tool, and I think we have it animated, yes. So it's going to start the security tool, and in this case that's going to be ping, and it passes in whatever arguments it's gotten from the API as it was started, and then anything additional, maybe in the script you'd like to hard code some options that you don't want the user to know about or have to worry about. But it's going to kick things off, and it's going to wait for those results to come in. Once they do, typically the model that we follow is the security test dumps its results into a file. So that could be XML, JSON, it could be any format at all. But this is the part where things can get a little tricky, which is parsing those results and interpreting, if this piece of information is here in the file, then we want to call this a fail, or we want to call this a pass. We also have, in this case, we just have a pass or fail. We do have the concept of informative tests. So certain security requirements, it's really hard to test them in an automated way. You need a person to come in and look, or you just need to establish a baseline. And so we can run tests that are informative only, that come back to the system. They allow a security architect to go view those. They can still run those at scale and see all of the results in one place. And we still have confidence that it's the same process every single time. I'm about out of time, so I'm going to have to jump pretty quick. But yeah, once everything's done, it's just going to come back to the Norad cloud, and you're going to be able to see it in the UI or via the API, like Brian was demonstrating. There are commands in the Norad CLI to actually build your images. We tried to abstract out a lot of the, even though Docker does a great job of having a pretty simple API in terms of what you type in on the command line, we tried to add a little bit of an abstraction over that, just so not everyone who's developing tests has to learn Docker. I'm going to skip through the unit tests. Okay, so some of the stuff that we've got going in Cisco, we have some, I think the main third-party one that we use is for leveraging the quali scanners that are deployed throughout Cisco already. We use open source tools like Volz, that Brian was showing, Zap, which is a web scanner, and Serverspee, which I think I'll talk a little bit more about quickly here in just a moment. And then Brian was talking about the requirements interface. So within Cisco, we do have the concept of I think it's the Cisco Secure Development Lifecycle. Lots of companies have things like that, and we are able to structure our tests specifically for requirements that Cisco has that other people may not be interested in. So it goes back to making the tool adaptable to whatever you need to work on. One open source tool that we rely heavily on is Serverspee. Some of you have probably heard of that, but from a very high level, it's a DSL for checking server configuration. It's a way to build very customized tests. And this example here, it's going to run authenticated on a box, and you can describe the file that you want to look at, and you can test for things in its content. So here we're just seeing if we have a secure SSHD configuration and an SSH client configuration. It's very extensible, very powerful. It can do a lot of different types of checks. This is a fraction of what it can do. You can use it to run commands. You can see if packages are installed and things like that. It has an abstraction layer over the operating system, so you can write tests with the same file that will run against multiple popular operating systems without having to have different source code for each one. Finally, I'm going to talk about a couple of the API clients that we have in terms of being able to instrument all of the different features in the API. We have a Python SDK. The reason it's written in Python is because we had someone else on our team jump in. We wanted the users in Cisco needed something written. Most of what they do is in Python. So we've got a Python SDK that wraps the majority of the API. We've got a API package written in Go. I've been working on that recently because we are also working on a Terraform provided plugin. Terraform is I think a pretty popular infrastructure as a service tool, a DevOps tool for describing your infrastructure and resources. And so we've been working on leveraging that to let people add their machines, their orgs, their tests, etc., into Norad via that. We do have all the API endpoints documented, and this is available on GitLab. We're open source at this URL, norad.gitlab.io. There's, 10 or 15 some odd packages there. And we are under the Apache 2 license, so you're free to do with it as you wish. So just to wrap up, we want to be able to be configurable, take all of this different testing paradigms, all these different tools, package them up into one nice little robot that can do all of our security for us. Thanks. We got 1 minute for any questions if anyone has any questions for any of us, or we can talk after.
Yeah, laptop. Oh, this? Yes. No. So Gary,
I love that bar.
Gary will try to give you.
CTF, Lockpick Village. I know they're taking donations for Hack for Kids, etc. Got some awesome prizes again. So feel free if you would like to participate in the CTF. Get the registration info upstairs. can come back down here. The wireless access is good from down here. So, thank you, sir. Thank you, guys. Thank you very much. Thanks for killing it as usual. You guys coming out this evening? After party?
I don't know. I think